Ah, mais il n'y aura que le stream là. Est-ce que tu le vois, le stream? Est-ce que tu vois? Et lance-le, et normalement, tu devrais voir ma tête, mais pas trop longtemps. J'aimerais que tu sois surtout slideshow là-dessus. Je cache ce truc.
Là, on voit le slide.
Et ce truc, on ne peut pas l'enlever là. La parole est à Sylvain. Hop. OK. Et du coup, pour le Zoom, tu fais bon, je pense pas. Ah non, attends, je repars sur le programme. C'est non, pas celui-là, peu importe. Tu casses pas tout, hein? Là, il y a le... Hein? Il y a le live stream. Voilà, t'es co-host. Est-ce que tu peux aller dehors de l'amphi avec ton ordi et on va vérifier qu'on ait tout le son et tout ça comme il faut. Tu me dis si tu as l'image ou l'image, je la vois là, mais le son. Est-ce que tu m'entends bien?
Oui, je t'entends.
Est-ce que tu peux aller dehors de l'amphi avec ton ordi et est-ce que tu m'entends pas? Est-ce que tu m'entends?
Encore plus
Bon,
fort
parfait.
là. Je me suis entendu en écho.
Tu peux re-rentrer, hein, Hermès, c'est bon, merci beaucoup. Yeah. Non. Les plénières, elles sont live streamées sur YouTube. Donc, c'est en place, ça. Est-ce que tu m'entends?
Oui.
Ah, mais c'est le live stream, ça? Un décalé.
Je coupe. Bien vu.
Masqué.
Donc oui, je t'entends.
J'entends ça. Et coupe ton son et tout de ton côté pour pas que tu aies de la scène. Mais c'est bon. En gros, quand il y aura des questions, il faut prendre les deux micros. Là ou là? Non, reste là. Mais je te file un micro. Il y a un deuxième helper avec toi normalement. Tu as les micros, donc il faudra les faire circuler. Je fais ça lui aussi. C'est pareil pour le deuxième helper. Marche pareil, les deux qui sont chargés. Et à la fin, il y a met un peu de temps à démarrer ensuite. Tu vois, là, quand c'est calque, ce qui n'est pas démarré, il va afficher le temps, 7 heures.
Ok, il faut que j'anticipe.
Ouais.
Test. Je pense qu'on peut parler un peu plus loin du micro.
Tu peux changer.
On va s'aimer.
Thank you very much.
Yeah, okay. Okay, see. Yes. So you have the possibility to get either my laptop exists. So this one is connected. So the thing is that we are hybrid on plus live stream on YouTube. So you either can pass me the your presentation and I copy it on this computer. It's PowerPoint, PDF, whatever.
It's all on Google Slides.
Google Slides.
Yeah, so for example, I could even log in or I could send you the link.
Yeah.
Yeah, yeah.
It's even easier.
You should have access to it wrong. You don't. And no, I should think that I don't. Someone just said that once. No.
Can I help?
Yeah, yeah, please.
Okay.
It's in my scent.
Good job. We can use my Gmail.
Okay. That's the link. That's the link. Yeah.
I mean, can you provide a copy?
Right. Compose. Does it say?
Got it. Yes, I guess it's stuck somewhere in the university.
Okay. That's the one.
Yeah.
The thing I want to check is because it's open now in your account, the videos might need to reload. So if we just check, if I just go through. It's good. We just probably look at the videos. Oh, there's another one. That's all good. We're good to go. Thanks.
Yeah, thank you.
You don't remember any problem? I do actually. I do.
I work for you in.
I know.
So how are you?
Yeah, very comfortable. Did you not see your previous? Yeah.
Last.
Yeah, I still do it.
Yeah. So it was very fast. So how are you?
Yeah, really good. Really happy.
You still been married, right?
That's right.
Yeah.
Yeah.
Great. So I will be introducing you.
Oh, okay. That's right. You know, nice.
Yeah. Yeah, fine. Still at being. So
You're sharing the presentation.
yeah.
So I'll be presenting the slides at the opening together with Dennis.
Okay.
And then give you the floor just after.
Yeah. That's fine.
Awesome. Thank you.
Okay.
Oh, yeah. So is so Anna, but she hasn't been in contact. Do you know she's here?
Yeah, she's here. She's here. You want to?
No. I mean, I'll catch you later.
I mean,
But I was asking how you talk. Because I know the slot is 1 hour.
yeah.
But is it? It's still about 45 minutes.
Yeah. So I will take 2 minutes, 3 minutes to introduce you, and I can go, and then maybe 10 minutes to.
So when you were at SXP, you were in
That was crazy, interesting project.
So what sort of stuff you doing?
No, well, right now I'm working with what I'm still doing evolution neural networks, but now with the sustainable goals in mind, we're trying to reduce the energy consumption. I'm also working on combining Mongo, which are alternative transformers that you have to mix there. And on also sexual evolution, on sexual selection, introducing sexual selection from nature into evolutionary algorithms.
So to model nature,
Yeah.
also do more efficient optimization.
You know, to try to improve the performance of the algorithms of basically our goal is always optimizing.
Yeah, so it is to improve the
Yeah,
optimization.
And
Because another way could be to try and model nature.
yeah. So the interesting thing with that is that we can get the benefits of bottom evolution where you are focused on quality, so thickness alone, but you can introduce diversity, which is really cool. So yeah, that's the one part from the project with the industry focus on LLMs, support, embeddings, stuff like that. So yeah, I also like those kind of projects that you had with the travel hub.
Yeah.
And well, that's what we've done right now as well.
Yeah.
So you use the game AI for what I see. Well, you were at Medley.
Yeah, I was at Meta for a couple of years, and I've been back 3 years now, and it's really interesting. So I'm doing a lot of applying Keynote to real world problems. So I'll probably do that more than I've been getting.
Okay.
Yeah, I've just set up. Yeah,
Cool.
to do this. At the moment, it's just one.
Okay.
But I got my first contract with Huawei.
Okay.
And that's pretty cool. So we're doing this sort of work I do for troubleshooting on telecoms networks.
Yeah. Okay.
Using it's a kind of a agentic framework approach for user and simulation and reinforcement learning.
Okay. Cool.
Doing some work with events in this one. Also
We are also back with stuff right now with the keyboard, which basically what's cybersecurity. So we are in context. The world is changing. Indeed. Yeah. Some of the problems are moving, but that's interesting. The game AI for
it's like real time strategy game.
yeah,
But it's not necessarily a game.
yeah, but you can model it.
Yeah.
In fact, I looked at this team that was working on network optimization, and we end up using reinforcement like where we want to optimize the assumption for some methods, and then we modeling it like a game as well. So yeah, it's really interesting to do that. So you still are you in London or you still living in Essex?
So I went to when I moved to Queen Mary. I lived there for about 4 years.
Okay.
But back in
Okay.
I just commuted once or twice a week.
Okay. Yeah.
They're pretty nice.
Yeah. I remember I enjoyed Essex. The city was really was calm.
Yeah.
It was really nice. We need to talk a little bit more about research.
Yeah, definitely.
Been married. Was always there. He's a campus for that. But then I spoke with Diego and Luca.
No, I think that was there.
Yeah, that was probably not, so everyone was in 2021.
I was also not that.
Yeah, okay, yeah,
So I wasn't.
So yeah. So I was, we were over there for, well, I was not traveling at that time, and so I went with all the stations. But even though it was really very cool.
Yeah, it's funny, all the kind of restrictions of COVID, it seems, I don't know, to me it's like such a kind of distant memory.
Yeah. 6 years past, and it was like 10 years. Yeah. It was cool. How do you this project and the travel up? Did it bring to nothing or?
It just kind of, well, reached a complete.
Yes.
It's not just like.
Yeah.
In fact, I think that it was probably transfer from it, but I think it's not.
Yeah, so you.
And so, yeah, that was.
Because I remember at the time there were the other school and as it's like the other department.
Yeah.
And
So I moved between areas here, about there.
okay,
So when I was at school, and that was pretty cool.
Yeah.
It was a nice job for a couple of years. Yeah, I was head skate crew there for about 3.5 years.
Okay.
Then I stepped down. Well, and that's a really nice opportunity.
Yeah.
But I didn't do much so
Yeah, just
we were more kind of so we're doing interesting stuff with simulation based testing. Okay, that is very product focused on this kind of testing framework. Sequence is good. Process makers on this. But yeah, it's a kind of focused on this. We wrote a couple of papers already, and I'm protecting this. And I was only able to do it, so sure.
okay,
So I just went. And I think it was quite nice.
Oh, all right.
Hey, good to see you.
Yeah.
Super ready.
Yeah, absolutely. We've even done an A/B check, so it's all good.
Okay.
Oh, it is a nice one.
Yeah.
It's a nice city too.
Yeah. It looks very nice.
Really, really nice.
I didn't have any expectations. I didn't shift it or anything there. I mean, what? This is a nice location. I'm about to take something else. So you still have your contract with Mary?
Yeah. So I just went down to a partner contract, so I full contract met that. And I just kept some of the impact full time. Yeah, so full time, plus I got on the side. Being here is good, so that's fine. So it's pretty. I plan to launch research grants to others really hard to get.
Yeah.
So.
Since you left the union, you can now apply for projects at least.
We can get that.
You can, okay.
Yeah.
That's
Yeah.
one thing. At least as a partner, you could always be.
As a partner, but I think we're going to apply
As
primary.
yeah. That's good. But yeah, good. Get at least from our side.
So for me, the research council funding is really hard. But I've got a nice relationship with the defense contractors, and they just probably have to say something to people who don't do the contract. You need to submit a proposal tomorrow, and it could be okay the day after. It's brilliant. They're just not good with contracts.
Yeah, I also have some the options, but they are always small tasks. But in fact, in also we have kinds of projects that we can one for funds together we come and have a big chunk just to as a minute, which is really cool. But you have to split it bigger. But you have to be partly.
Yeah.
But that's they are competitive, but it's a lot of life.
Yeah.
You can manage. That's fine. We do more research.
Yeah.
This kind of goal. Sure. Just what to say.
You had it wrong. We'll just come down.
No, in the allergies and so that's
Just like any history, you know.
yes,
Yeah.
it's kind of hard to tell the people, but it's just our in between.
I don't listen on the local work.
Oh, yeah, Simon.
Very nice to meet you.
I don't know about actually, I haven't had a chance to do a checking.
That's okay. We know who you are.
I better clear off and.
Yeah, so
Yeah,
we have a little opening presentation.
yeah, I saw that.
And then we'll introduce you.
Nuno's gonna introduce me, right?
Exactly. And there's. Keynote and will you be staying the double conference today?
Yeah, until Friday lunchtime.
Oh, wonderful.
Yeah.
Great to have you.
Yeah. In fact, I went to the, I tried to find the student reception yesterday.
Oh, no.
I didn't know what, I didn't know that. I was quite late anyway. So I went to the room and there's like nothing there. So, hey, nothing to see, yeah.
They wrapped up very early.
Oh, I see. So I didn't, no, sorry.
Best of luck.
Yeah, it's, yeah, we got there, so I got it just before 8, and I just thought it was 3 years, and,
Yeah.
but no, it all wrapped up very late.
It all wraps up pretty early and then actually kind of like the bar and then. That's the unfortunate.
Yeah.
The cards don't work. But I think it has to be there. Yeah. Yes.
Hello, everyone.
I was going to say that. That was my sentence.
Welcome to Toulouse. If you can all find a spot.
Hello, I'm very happy to have you all of you here in Toulouse. My name is Sylvain Cussat-Blanc. I'm a professor here at University Toulouse Capitol, and
I'm Dennis Wilson. I'm professor at Isaïe Supero, which is not where we are, but which is also in Toulouse.
so to start, where did you land it? Where are you? I guess you know that you are in Toulouse now. And just a brief introduction of what is this city. So it's a kind of old city that hasn't been destroyed by the World War. So it's why you have all this nice building all around. It's known as the Ville Rose, the Pink City, because of the color of the building that are made with bricks, basically. And as you might have seen when you landed on the airport, there is a big Airbus factories here. So this is the big center for aerospace and research. It's also a very strong community. There is a strong community of researchers with more than 100,000 students inside the city, which is about a quarter of the population inside the city. So that's Toulouse, and you will be hopefully able to discover a little bit of this, let's say, unknown gem in France, because basically you know Paris and Nice, but Toulouse is a wonderful city too. Here we are at University Toulouse Capitol. It's one of the oldest university in Europe. It's specialized in economics, in law, and interdisciplinary research. So not computer science. The main computer science campus is outside of the city, but it has the big advantage for us to be very close to the city center, and you can enjoy also the city by being here. So what is EvoStar? Sorry, EvoStar is actually 4 conferences that are together. EuroGP, which is the European Conference on Genetic Programming, Evo Application, which is the European Conference on Application and Evolutionary Computation, EvoCop on evolutionary computation in combinatorial optimization, and EvoMuseArt, which is AI for music, sound, art, and design. So it's all these conferences that will be all together in all the sessions in parallel during this week. In addition to that, we have EML, which is a joint track between Evo Apps and EuroGP, and late breaking abstract, for which we have some posters that are here. So let's talk a little bit about logistics, how the conference is going to happen here. So you might have seen us already. We have this pink t-shirts with crew behind, if you saw. This is all airports. If you have any question about what happened in the conference, we are more than happy to answer and to solve the issue that you can have. All the session will happen in this building. Basically, all the rooms are here. So you are in room A, named Rampart 1. Rampart is the name of the building in the university. And all of the sessions are in this building. So you have another theater, which is Rampart 3, which corresponds to room B. the room R108, sorry, which is room C, which is upstairs here, and room D, which is R10, which is downstairs. Basically, if you want to optimize your trajectory, you just, if you want to go to room C, you can escape through the upper side of the amphitheater, and you're basically in room C. And if you want to go to room D, it's just go in this direction downstairs, and you are just in room D. So you don't have any floor to climb if you are in the theater at the end. Wi-Fi. If you have access to eduroam, please use eduroam as a preferred network. If you don't, you have in each room, either on the desk or in the entrance, the instruction to connect to the Wi-Fi, and it's also in the registration desk. And if you have any issue, once again, please just ask us, and we'll help you to connect to Wi-Fi. Here is the program overview. So of course you have access to it through internet, but it's also displayed here and there in the building. So we have 4 parallel sessions every day and 3 on Friday. All sessions are in hybrid mode, so everything is on Zoom, plus of course in person here. And the way we are going to do that for question is that if you have a question in the room, you just raise your hand. And if you have a question online, you just raise your hand, but virtually. So, and then the helper will tell the session share that there is a question. For the people that are online, please keep the microphone off and the video off to help us to reduce the flow. If you don't want to attend the session, which I don't advise you to, you can use the theater in between 1 and 2, which is number 2, which is for us also, and for you to work in the quiet place. It's open. You just enter and go wherever you want, and you can work over there. In Friday, we will have a closing session at 12:30 here in the same room, and we will announce the best paper and other announcements, also other awards that will be distributed. After that, if you are interested in what happened in the Species Society, which is the association that is organizing this community and this conference in particular, there is a general assembly just after the closing session, so Friday afternoon. We have a final optional excursion on Friday afternoon, and unfortunately, we wanted to have a guided tour, which canceled because of health issues. So we have the Dennis's tour of Toulouse, and is currently learning the history of Toulouse, and to be able to show you different places, different monuments, and good place to taste food, local food. That's the most important part. If you want to attend, and I strongly advise the 180 of you to attend this wonderful tour, you can register at the registration desk. You'll get a ticket for that. It's free.
But limited to 40 people.
And Friday afternoon. Food, which is very important also. More food. Everything, again, will happen here. You might have seen already the tables that are set up, so you will have all the breaks that in the main hall. And because we are lucky to have nice weather this year at EvoStar, which is not common apparently, we can use the outside part of the building. There will be food also that will be bring there. Allergies are listed in the main registration desk. The caterer will display all the allergies for those that need this information. The poster session will also take place in this building. In the main hall, you saw also the poster boards that are already in place, and we'll have the cocktail to help us to understand all the posters. If you have a poster to present, you have a number that is on the top right, on top left part of the poster board with your paper ID. So please use stick your poster where you with this number, and you have tape that is available at the registration desk to help you set up the poster. There is a prize to win if you attend the poster session. So attend the poster session. More food. The conference banquet will take place in Domaine Rochemontes, which is about 45 minutes away from Toulouse. It's the castle that you can see. Sorry, the castle that you can see on the top images here. It's a very nice place where you'll have the view on the Garonne, which the river that is going through Toulouse. So we need to meet like 200 meters away from here. You have the map. I don't have the pointer. You have the map here. Yes, I have the pointer. So we are here, and we need to meet here the buses. We'll have helpers that to guide you all the way to the buses. It's pretty easy to go, very easily. We'll do the group picture in front of the castle. So basically, really here. That's the best spot that we can find for the group photo. So make sure that you are in front of the castle at 7:15. I forgot to say, sorry. The buses are leaving at 6:15 max. So if you are not there, unfortunately, we won't have any solution anymore. So be sure to be at 6:15 maximum at this point here, where at the bus pickup point. Back to the group photo, so the 7:15 in front of the castle, and then you'll have a cocktail followed by the dinner, which take place on the castle itself. So it's a side building here, and you'll be able to return to Toulouse at 11:30. We'll see, but around this time. And I leave the mic to Dennis for the keynotes.
Just a final logistic point, there will be a videographer tomorrow who will also take the group picture. She will be filming the full day to make a EvoStar video. If you'd like to not be a part of that video, please let us know at the registration desk. So, a part of EvoStar that we're very proud to have is 3 excellent keynotes this year. We have Simon Lucas, Jean-Baptiste Moret, and Guy Terraleuse. So today, shortly, and I'll try to wrap up quickly, we're very happy to have Simon Lucas from the Queen Mary University of London, who will be talking about evolving game-playing agents with LLMs. Tomorrow, we have the Julian Francis Miller Award going to Jean-Baptiste Moret at INRIA France, who will be talking about quality, diversity, and the Map Elites algorithm. And our closing session, the local keynote, is from Guy Terraleuse, a researcher here in Toulouse, who will be talking about the dynamics of moving together in fish schools and autonomous swarms. All of those will be here in this room and also live streamed as this opening session is. There are Best Paper awards for the various, for the 4 conferences. The nominees for those Best Paper awards will be presenting in the same session, and you will be able to vote by attending those sessions on site with a token. And the results of those votes will be announced on Friday during the closing session, along with our Outstanding Student Awards, the Best Student Paper, the Best Poster Award, and the EvoStar Dissemination Award. We'll be giving out some nice prizes to those, as well as to the winners of some of the optional student activities. We have a great Toulouse scavenger hunt that we've designed for the students. So while we hope that you are spending your entire time at the conference, if the evenings or other time you would like to explore the city, there is that you can participate. Non-students can also participate. And last night we had a nice welcome reception for the student. And on Thursday, there is a student workshop, which experienced researchers are also welcome to attend, but it'll be here without any other sessions planned. And that the goal is for students to discuss with experienced researchers. There are also members that you'll see with badges with little pink, with little purple pins on them. We are the EvoStar Purple Squad, first responders for any violation of the EvoStar Code of Conduct. If you're not familiar with the EvoStar Code of Conduct, I encourage you all to read it on the website. It's about the type of conduct that we expect from conference participants throughout, and we ask all of you to respect it. Friday, after the keynote and after lunch, there is the general meeting of the Species Society, who are the organizers of EvoStar. By attending EvoStar, you are all registered to be members of that as well. And if you'd like to take part in its organization and understand how things like EvoStar are organized or other things, you're welcome to attend that AGM on Friday. Species will also be posting information about the event throughout the conference. They'll be doing that primarily through their LinkedIn account. And if you'd like to post or support the conference online, feel free to follow them, follow their activity, repost their activity, like it, and comment on it. If you're still on x.com, feel free to tweet EvoStar 2026 and mention the EvoStar Conf. Species does many things besides this conference, and I'd like to talk briefly about some of the other opportunities that they offer. So there are scholarships of 90-day internships. I myself have benefited from hosting one of those, and it went very well. So hosts and candidates both apply. You see the deadlines here for those. And then there's notification of eventual matches between hosts and candidates. And the scholarships start this year at the very latest at this date. Honestly, from my experience, it was one of the most fluid sort of internship funding experiences I've had. So I highly recommend it for hosts as well as for candidates. There's also an excellent summer school, which will be happening from August 26th to 31st. It's going to be happening in Moraya, Spain. So you can still register. This says August 2025 for the photo, but it is this year in 2026. It's up to 16 students, and there's free registration for the first 5 female students that register. There are also travel grants if you'd like to attend. So feel free to talk to any of the species members, Anna, Panusel, if you're interested in the summer school and you'd like to spend a part of your August here at this nice beach learning about evolutionary computation. So this year's edition of EvoStar is brought to you by a team that's been working hard for a while to organize all of it. I'd like to thank all of our student affair members who did a wonderful reception last night and who will be organizing all of these student events throughout the week. If we could quickly thank them. You have the entire local team in our pink t-shirts here. Sylvain and I are the general local chair, so any questions that you have for us, feel free. And we'd also like to thank Yuri Lavinas and David Simoncini, who've been helping out a lot for the organization over this past year. Finally, Sylvain and I went slightly over budget, and so this EvoStar wouldn't have been possible, a visit to a castle and all of that, without some generous sponsorship from various institutions around Toulouse. We are very proud to have their sponsorship from members like IRT Saint-Exupéry, IRIT. These are local members who are very invested in artificial intelligence and research in the domain, and seeing that they're interested in investing in evolutionary computation, I think, is a great mark. There are 2 universities, ANITI, which is Toulouse's Artificial and Natural Intelligence Institute, IA pour la Santé, which is a organization and project around ANITI focused on health, and Jolly Brain, a startup here in Toulouse focused on AI. So we're very happy to have all of their support for this year's conference. Now, I will leave the floor to Nuno for our first keynote.
Hello, good morning. I'm not the keynote. I'm here to introduce our guest. So I'm really pleased to introduce our speaker today, who understands that if you want to build AI that can navigate the complexities of the world, we first need to teach it how to play. Professor Simon Lucas is a professor of artificial intelligence at Queen Mary University of London, where he leads the game AI research group. He has served as the head of school at Queen Mary, and recently he worked at Meta, working on their simulation-based testing team to solve complex automated testing challenges in the world. Simon's impact on the global research community is hard to overstate. He's the founding editor-in-chief for the IEEE transactions on games, and the co-founder of IEEE conferences on games. Whether it is groundbreaking work on Mount Carmel research, Rolling Horizon evolution, or his current explorations into large language models, his goal has always been the same: creating AI that is more efficient, more adaptive, and more intelligent. He's here today to share his insights on how simulation and game-based intelligence are shaping the future of technology as we know it. Please join me giving a very welcome to Professor Simon Lucas.
Thanks, Nuno, for the kind introduction. And thanks to Anna and the organizers for inviting me to give a keynote at this wonderful conference in this amazing city. And it's fantastic, actually, looking around the audience to see so many familiar and faces of old friends. Really wonderful. Yeah, so my talk today is involving gameplay and agents with LLMs. And let's get right into it, if I can get this to work. Okay. So the outline, I think, so despite amazing progress in AI and LLMs, I think the best models have really serious, and this is a kind of arguable point, but quite possibly insurmountable limitations in their reasoning abilities. And this is also called the knowing-doing gap. So if you discuss complex problems with LLMs, or, for example, give them fairly hard games to play, perhaps even easy games to play, they will tell you in great detail how they're going to play the game really successfully. And then their actual performance, as we'll see in some examples, falls really, really far short of that. So there's a kind of knowing-doing gap. They can explain how they're going to play the game, but actually are really poor at doing it. So what we do with simulation-based AI is we use simulation models of a problem domain, and then we just do exploration within the space of the simulation by simulating lots of possible action sequences. And the idea is we're going to optimize these action sequences in order to make good moves and have sensible, intelligent behavior. So I think the idea itself is really kind of simple, and I find it a very, very compelling idea. So the overall idea of this talk is I'll look at simulation-based AI and also evolutionary research, which they combine together really nicely. And I think provide an ideal complement to LLMs. So we can use LLMs for all kinds of good things, like writing code, developing simulation models, optimizing heuristics, all this kind of thing. And in many cases within an evolutionary setting. So we're coming up with hypothetical solutions to a problem, and then optimizing this to make it better and better. So we'll look at some recent work also on probe search with LLMs. And I'll also talk about a competition that's quite dear to my heart. I'm organizing it at the moment. It's called Planet Wars AI, and we'll see how things are doing with this. So LLM limitations. LLMs are really amazing for language generation and recognition. They just generate amazingly fluid text, amazing coding agents, but they're really poor at strategic reasoning and planning. And I say, when I say they're really poor at this, they're not always poor. You can get Claude to write code for you, and it'll make a plan of what it's going to do. So in that sense, it's actually quite good at doing these plans with a few items in it. But if you look at planning in more complex, let's say different domains like game playing or strategic reasoning, and you compare them with good agents in those domains, that's where they really fall short. I think though they really form a part of a good sort of hybrid agentic system. And we use LLMs with tools and also tools with LLMs. So I look a lot at simulation-based AI together with LLMs in order to generate sophisticated agents, complex intelligent systems. And I think there are 4 distinct paths for this. So one is we use LLMs to enhance traditional search and optimization algorithms. And we use this to generate heuristics. So these are heuristics for policy functions or value functions. And this is really low-hanging fruit. It already works, very successful. But just because it already works doesn't mean we shouldn't do more of it. We can make it better and apply it to more kind of domains. So this is really, really useful things. We can also use LLMs for algorithm development. And this is a very active field of research. And I'll talk a bit more about this with the program search for games and program search in general with LLMs. And I think there are huge potentials to do more with this. And most of the work so far has been on evolving fairly small programs. And as you try to scale this up, I think it doesn't work brilliantly yet, but there's obviously plenty of scope for it to work better. The third point I call simulation control. And in simulation control, we're trying to get the AI agent to use simulations in the same way that an expert engineer would. So if you think about a kind of standard RL problem, we just say, well, here's the environment. You've got to optimize your reward in that. But if you try to tackle a complex real world problem, it's not like that at all. Part of the problem, or I would say a major part of solving that problem, is developing good enough models of the problem domain that are going to help you to understand that domain and be able to do planning within it. And then the final one is learning and writing world models. And if we don't have a good enough simulation model for a domain, then we can use LLMs to help us generate it. And that's also an area of great interest. So I'll talk a lot about what is simulation-based AI. And here are a couple of favorite algorithms. So the top one is Monte Carlo tree search, and the bottom one is rolling horizon evolution. We're going to see plenty more of rolling horizon evolution, which is good because this is an evolutionary algorithms conference. So the basic idea is we use your forward model to plan, and that is to consider possible future scenarios. So we're going to make decisions based on the statistics of these plans, and we're going to optimize these plans to try to find plans which are going to lead to good outcomes. So in Monte Carlo tree search, we do this by doing lots of random rollouts and building a tree selectively. And in this example up here, there's more reward towards the right of the picture. And so you can see the trees being built selectively towards that area. There's a funny thing about Monte Carlo tree search, and it's actually a whole class of algorithms. There's literally thousands of different variations of this. But in the standard case, you do a rollout and you just use it to add one node to the tree, and you throw that rollout information away, which for some domains is a kind of silly thing to do. And if we contrast this with rolling horizon evolution, here we have a population of complete plans that go until the end of the planning horizon. And so we're retaining all that information. And if we found a good plan of action, we're going to keep it, and we're just going to optimize that plan to try to make it even better. This is really, really useful things. With all these things, we can start with random actions or policy, and we just work towards more favorable outcomes. It also works very well with learned policy and value functions, and this is seen with things like AlphaZero. We can also make it easily multi-objective. So unlike conventional RL, where it's a little bit hard to do that, with these algorithms, because we're just selecting things on the basis of a preference function, we can make that very easily multi-objective. And I'll put in bold there that simulation may be the key. So for many complex domains, actually getting a good enough simulation model is the hardest part of the problem. And then when you have that, you can throw a whole variety of standard algorithms at them, because once we have this sort of standard copyable forward model, it unlocks a whole set of possibilities, right? And in many domains, we don't just have one simulation. We're going to develop multiple simulations, and then we can do planning at various levels of abstraction. So we do like a high-level plan and then more detailed low-level plans. So this is, you got to pay attention really quickly to the video because it's going to change. That one there is with a short planning horizon playing asteroids and it crashed. We're now running again with a longer planning horizon, and it's able to do this. So what do we need to do this? We need this fast and copyable or revertible forward model. And the simplest algorithms of this nature, they're really simple, just a few lines of code. These algorithms are somewhat explainable, so we can look at the outcome of the simulation and understand why the algorithm's chosen that particular course of action. And they're also very tunable. So by tuning the planning horizon, we can make them nearsighted or farsighted. There's also a kind of optimization there, because if we make the planning horizon too long, then we're making the optimization problem itself more difficult. So we need to do some sort of tuning there. And we can even have variable horizons for given problems. We can make it thorough or slapdash, consistent or erratic. And what we find is that random rollouts and then optimizing those, just standard kind of evolutionary stuff, this provides good performance across a really wide range of domains. And it's so simple. I really like it. The other thing is, very often you look at the individual rollouts and they give a very poor idea of the quality of the solution, because we're applying this in rolling horizon mode. We're doing optimization all the time. And if you look at any particular rollout, you say, well, you know, it's not leading to a feature that's good. But actually, because we're optimizing all the time as we're playing the game or solving the problem, it often leads to much better performance than you would expect by looking at the statistics of it. And so even if the rollouts themselves gives poor estimations, the key thing is that if there's information in the rank order of those rollouts, then we're still going to get good performance. Okay, so not actually code itself, but a bit of pseudocode. So this is my favorite algorithm, right? This is rolling horizon evolution, and you can code this in as many lines of Python. So at the start of a game, or the start of the planning problem, we're going to have this thing called best sequence. Best sequence is our current plan. We initialize this to a random action sequence of length L. So L is one of the parameters. So it's essentially 1+1 evolutionary algorithm, but done in rolling horizon mode and using our forward model. So we say best sequence now is shift and random append of the current best sequence. So we're going to take the first action and all the time add a random action to the end. And then for a number of evaluations, we'll say the mutated sequence is a mutate of best yet. And if the score is better than or equal to the current best score, then we assign best sequence to the mutated one. And then we're taking the action in our game or domain by returning the first of best sequence. Now you'll notice that I've colored these random things in different colors. So green is where we could plug in a policy function. So instead of having pure random, we plug in a policy. We do some sort of softmax sampling, okay? So very easy to plug in learn policies. And then the blue one for score is where we can plug in a heuristic value function. So this is of key importance. Sometimes we've got planning domains with very flat reward landscapes. And so if we look at the true reward within the planning horizon, it may be completely flat, right? So there we need a heuristic that's going to tell us, well, actually, you know, although you're not scoring anything, these sort of things might look better than other things. And we're going to see an example of doing exactly this with an LLM coming up in a minute. Now, this is an old version of Planet Wars, and this is Rolling Horizon Evolution in action again, this time playing a two-player multi-agent game. The cool thing about this is that this is exactly the same algorithm without any extra training that you saw playing Asteroids. So it's just showing, and it's the same simple 1+1 EA, right, that you saw in 5 lines of pseudocode on the previous slide. And it's just evolving these sequences of numbers that's saying send ships from planet A to planet B encoded as integers, and it's just evolving that and playing in real time. So the previous demos have been the most basic Rolling Horizon evolution, but we can tune this in all kinds of ways. So we can do tuning the parameters, including using LLMs for policy and value functions. We can use opponent models. We'll see a bit of this later too. And we can learn simple models in real time. So for many years, there's been a fighting game competition associated with the IEEE conference on games. And together with colleagues in Beijing at the Chinese Academy of Sciences, we did some work on using opponent modeling with this. So previously, the first versions of the fighting game competition had been won with rule-based systems and then Monte Carlo tree search. And then we applied rolling horizon evolution to learn an opponent model while playing the game. So we exploited the fact that each of the matches is a best of three bouts, 3 individual games. And so the first game we essentially throw away and we just use to learn an opponent model. And so we're not very good in the first game, but in the next 2 games, we beat the opponent because we've learned a model of what the opponent's going to do. And then we plug this into a rolling horizon algorithm, and we're able to do this very successfully. So more on games as benchmarks. So we've had some very famous successes, things like AlphaGo, AlphaStar, Cicero was playing diplomacy. But there's still a challenging area. And I think novel games, multi-agent games especially, are the best. And there's a large space of variations, and they're open-ended due to unknown opponents. So unlike fixed benchmarks, I think of these as kind of living benchmarks. So providing the game is unsolved, you can pose this as a challenge, and I'm doing this at the moment, as you see with Planet Wars. And you say, okay, it's not solved because another agent is going to come along and beat the set of existing ones. And there's a nice talk on this by some friends of mine, these guys here, about what we can learn from AGI, from game AI. And the main upshot of this paper is that, people talk all the time that AGI is here, right? So some people say we already have artificial general intelligence, but if you try to get these systems to play complex games, they're really terrible. They haven't got a clue. Unlike humans, which are relatively good at this sort of thing. So in that sense, we're still quite far from it. And for people wishing to look at this more within our group, we've developed the tabletop games framework. And this gives a really nice challenging set of games, currently more than 20 games, including things like Terraforming Mars and 7 Wonders. So really complex games. And if you put the most sophisticated AIs onto these, they're really not very good. So plenty of open challenges there. So let's look a little bit more at kind of LLMs play games. And there's a really nice paper I want to point you to. I think it's maybe a year or 2 old now. It's called GT Bench. And what they did was take a number of LLMs and also with various scaffolding frameworks, chain of thought, all these kind of graph-based methods, RAG, thrown all of them at it. And what they found is that the LLMs lost basically 100% of the games against things like Monte Carlo tree search. Even on simple games like Connect 4, for which there would be lots of, lots of information out there on Wikipedia, on game logs and things that the LLMs could learn from. And even in those cases, the LLMs are losing basically 100% of the games. And why is this? There's a nice paper that came out of DeepMind looking at LLMs as greedy agents and the effects of RL fine-tuning on decision-making abilities. And they identified 3 problems: that LLMs are greedy, so they select the best action from a subset of the available ones, so that they're not even considering all the possible actions, but just making decisions in a slightly greedy way. Then there's a frequency bias, so they might select a frequently used action if it's very likely in the training data, even if, given what they know, it's not even the best of what they're considering. So that's like a frequency bias. And then there's a knowing-doing gap, and I think this is my favorite one, where they'll even identify the best move, as a kind of text string saying that this is what I'm going to do, and then do something else entirely. And I just think that's a really wonderful one. And we're going to see this this is a game I wrote many years ago. I was teaching a course on Android programming, and I wanted an app to demonstrate it, so I wrote Griddle. And we're going to look at statistical forward planning, which is like Monte Carlo search versus humans versus ChatGPT. We might not do the humans one. So here's a game, right? You've got a deck of letters. There's about 80 letters. It's made to be really friendly for making words in the English language, right? But it's so like 5 S's, 5 A's. There's only 1 Q. There's only 1 Z because they're less common letters. And so what we're trying to do here is make words, and you get points for making words. The longer the word, the more points. Words only count in kind of crossword fashion, so left to right, top to bottom. Once you place a letter, it cannot be moved. So imagine this deck of 80 letters is shuffled. You get dealt one at a time. So at the moment, we've got an A there, and we've got to place the A. That's the current task. And so if we placed it there, for example, we'd already score a point because that makes as. If we placed it there, make tar, another word. So that's essentially it. So we can describe this to an LLM. And this is, this is 3 years ago first did this. So I say to ChatGPT what we want. I'd like to act as an intelligent game player, describe the rules. And it's just brilliant at this. So it says, yes, I understand the rules. And yes, I want to play the game. Really, really positive, upbeat. I just love that. And it's written the rules back to me in a kind of better way than I'd written them myself. I invented the game and I wrote the rules, and it's coming back to me. I think I know the rules. They're like this. And I think, yeah, that's even better than I wrote them. Really good. And so it's talked about the importance of playing the certain letters in corners if they're going to be at the end of the word and this sort of thing. And then all it's doing is placing them left to right as they're dealt. So it's just going to lead to a random score. It's absolutely useless gameplay. Yeah. And then it's actually not applying the rules properly. So it's saying it's made these words like rum, but it hasn't. It's made URM, right? It's not made those at all. So I did this last year with ChatGPT, and now it's come up with a score of 54. And it's played a legal game. This was the kind of best that it got yet. But it's still not good. And if we compare this with information set Monte Carlo search, so this is a kind of statistical forward planning algorithm. And what we're doing, we're saying, we're considering each possible place we could place a letter, and we're doing maybe 100, maybe 1,000 random rollouts from there to say, if we did that, what would the consequences be? And actually the consequences of doing a random rollout, they're always terrible. But if you remember on one of the first slides, I said that the key thing is that there has to be information in the rank order. So it's really fascinating to watch the AI play this, to watch information set Monte Carlo play this, because as it considers the different squares where it could place a letter, you'll see that the best squares at the start of the game have a score of, 30.1 or something, and the worst ones have a score of 29.4. There's like very little in it. And it ends up with a score of 127. Really, really interesting, I think. Yeah. So in this case, each move was estimated by the mean of 100 random rollouts, and it plays a really good game. So the takeaways from this is a word game. We might have expected LLMs to be good at this. They know a lot about words, right? Words are their thing. But the spatial nature is really hard. They talk a good game. The recent versions of ChatGPT are the first to beat random, but vastly inferior still to simulation-based AI, and way slower, around 10,000 times slower than using information set MCS. So if you have a simulation model, you should use it. Okay, so we're going to get into a bit more of using it with using LLMs together with evolutionary search now. So we're going to look at this in the context of the Maritime Capture the Flag competition. This is the 2024 version. It's also running this year. And if you can see down the bottom, that's my face there. So I won the 2024 competition using simulation-based AI. So the idea is you've got to control 3 units per team, but you control them as a puppet master. It's not sort of distributed multi-agent. There's just 2 players, each controlling 3 boats. Continuous states, combinatorial action space. So the game runs at 10 hertz, and for your own team, you've got 17 to the power 3 actions. If you consider the opponent as well, that's 17 to the 6. So it's like a really big, this is a massive branching factor, right? And the long planning horizon, so each game, I think, lasts about 5 or 10 minutes. So fairly long. And the flat or deceptive rewards. So almost everything you do can end badly. So if you go outside of the area, you get penalized. If you crash into one of your own boats, you get penalized. And so, you know, the safest thing is to just sit around doing nothing. So to implement the SBA, I had to re-implement the simulation to make it faster and more copyable, but I did that and ended up winning the 2024 competition. So what we're going to see now, though, is an improved version that beats the 2024 winner. So the 2024 winner was actually, even though it was my agent, is quite disappointing. So because the game setup was so hard, I ended up evolving a fixed strategy, and that's going to be the team on the left as you see it. And then since then, the rules have changed because the rules made it so hard to attack, it was virtually impossible. And hence why I found that fixed strategy. So the current version is now much more interesting. And it's quite similar to the version I've got here, though not exactly the same. So what we're going to see, and I want you to look out for this, please. We'll see, first of all, there's a variation of rolling horizon evolution. We call it MURIA, multi-unit rolling horizon evolution. And what we're doing there is evolving separately plans for each of the agents, but in the scoring function, we're considering the combined effects of all their actions. But we evolve one agent plan at a time. It's just kind of easier to do that. And what we're going to see is, first of all, this technique not working due to the flat reward landscape. And then what we're going to do is plug in an LLM generated heuristic function. So now we're combining the LLMs with the EAs, and this is going to be quite effective. Okay. So to start with, I've slowed it down as well. So the simulation runs, I don't know, like about 10,000 hertz, and the game's playing deliberately slowly at the moment. So the heuristic now is true. So you have to watch that really carefully. To start with, there was very flat reward landscape, and all the things ended in 000, like 1,000 or minus 1,000, so on. Now we're running at full speed. Probably hard to see the exact numbers there, but what you're going to see is that we just, let's just stop this for a minute. So the thing to look out for are the health bars on the agent. So once a boat tags another boat, it loses its tagging ability until it recharges. And so the strategy that's being exploited and is searched for in real time in this multi-unit rolling horizon evolution is for one of the boats to be tagged, and then that opens up a gap in these 3 defensive boats here, and then it comes through and scores a point. So just keep a lookout for that. So that one got the flag now. And it's able to get through and get it again because the other one hadn't fully recharged. So in this case, we're getting something that's able to perform much better than the base algorithm by having this LLM generated heuristic. And this was actually done by ChatGPT with me in the loop as well. So actually the heuristic generator at that time by ChatGPT was sensible. It read the rules and said, okay, in order to score points, I've got to capture flags. But to do that, I've first of all got to get close to the enemy flag. And to do that, I've got to avoid getting tagged by the boat. So it's got a number of things in the heuristic, and it just wrote all the code for this really nicely. It had one error in it. It had the sign wrong at the end of the function. So the thing it actually generated was like the reverse of what it should have been. But with a quick fix, it was then able to perform well. Yeah, so at the time, interesting, none of the RL methods performed well at all. To apply SBI, I had to write a fast approximate simulation model. So software development effort, but the benefits are really significant, okay? So for any problem domain, if you've got to write a simulation model and you do a good one, then there's really scope to reap significant rewards for that. What we find also is if you have a good simulation model, you can make things really adaptive. And I do this, I've got another example of this coming up. But if the problem domain changes in some ways, you can just change the simulation quite easily, relatively easily. And that's often simpler than having to retrain an RL system. So there's a link there for follow-up work on maritime capture the flag. So let's have a quick look now at LLMs for iterative code generation. So I've listed some of them there. You know, there must be many more by now. So there's LLM for AD, Lamea, Fun Search from DeepMind, Program Search for games. That's our own work together with some other colleagues. Alpha Evolve, Open Evolve, Shinker Evolve. There are lots of them, and they all aim to take genetic programming to the next level by combining them with LLMs. Because as we know, LLMs are great at writing code, great in many ways at this. And I've shown this example above. This is evolving problems to the circle packing problem. So we're trying to maximize, I think, the sum of the radii for the circles fitting in a square. I've just put this example here. So this is discovered by the bottom one called Shinker Evolve. And this is, I think, the best, at the time of writing, the best known solution to date. But this is a kind of very artificial problem. And the LLMs are good at this. They're fairly small heuristic functions. But I think, I mean, personally, I think it's a very sort of artificial problem. And the better agents now, the better solutions are like 0.001% better than the previous ones. But nonetheless, that's quite a common benchmark. More or less solved, I would say. And I'm not sure how well they generalize to different numbers of circles, right? So if you say I want to pack 31 circles, how well does that work? So there are many similar systems here. I've picked the Open Evolve one. I thought they had one of the nicest schematics for this. So the idea is you've got a program database that stores programs and metrics. You've got an ensemble of LLMs. In many cases, you want to use many of them. Some are free, some are open source weights and code, everything, various levels of performance. And for many problems, you find that there's no kind of consistent ranking in the LLM. So sometimes a small LLM might be really good, sometimes not. And so you've got a controller orchestrating this, requesting LLMs to generate code, using programs to evaluate this in the evaluator pool, getting metrics back, having a database of programs, looking at past programs, creating the prompts and so on. And all this is going on in some evolutionary loop. So it's a really, really powerful approach. And it's really genetic programming, I think, taken to the next level. So using LLMs to generate the code while using evolution to evolve it over time and try to make it better. I just want to pick out some notable features. So one of my favorites is Lamea. And I think one of the great things about this, it gives you also code evolution graphs. So you can see how the code itself is evolving over time. It's really nice. But maybe one of the most important things, it gives you a separate parameter tuning phase. Now, this is really important, right? Because the LLMs are really good at writing code, but a lot of code for complex problems is going to have many parameters in it, right? And to expect the LLM to not only generate the code, but also set the parameters, I mean, come on, that's like really, really asking a lot. That's asking too much. And so Lamea has a separate parameter tuning phase. You can plug in different tuners. The default one is SMAC, which many people in the audience, I'm sure know. So that's a nice approach there. And then the other one that I pick out, well, one of the other ones is LLM for AD, this from the group in Hong Kong. And their concept is evolution of thought. So evolving in parallel, you've got the code, but you've got the concepts in the code. So you might say, okay, I'm involving a Monte Carlo tree search algorithm. Oh, and actually it's going to have these sort of heuristics in them. I want a heuristic for capture of the flag. I've got to get close to the flag. That's my kind of idea that I'm evolving at the same time. So that's a nice idea, I think. Then Shinker Evolve is a fairly recent one. It's also got non-diversity rejection and also uses LLMs to critique the code. So LLMs generate the code, other LLMs critique it. And I think this is also really, really nice approach. By the way, there's nice work also by the Shinker Evolve people showing that with many of these systems, that they actually barely outperform a variation on random search. So if you use LLMs together with random search, you'll do almost as well. So it's shown actually a lot of the power is in the LLM generation function, and maybe less so in the details of the evolution. Okay, so let's look a bit at LLMs for writing simulation world models. So two main approaches to world models at the moment. You'll have seen the work from DeepMind, things like Genie and Genie 2, where they train foundation models on vast quantities of gameplay data and learn really impressive world models. But these are kind of slow to run and hard to interpret. Another approach to this is to have code-based world models. And for me, this is the most exciting approach, because we end up with code that we can then play with. We can do unit tests. We can run all kinds of integration tests and use it in very flexible ways. So this is one of the first papers on this, World Coder. And the idea is that you have lots of gameplay examples. They did the example of Soccer Ban. And what we got here is you've got a set of tuples of you're taking actions in some world. You get state, reward, there's a goal, and you've got all these tuples that you're sampling. You've got an LLM generating code. You've got a replay buffer. And all the time you're trying to get LLMs that are closer to matching these state, action, reward tuples. So the LLM's generating these closer to the actual observed data. When you have this, you can then plug it into your favorite planning algorithm, like Monte Carlo tree search, rolling horizon evolution, and this is very, very powerful. Works pretty well on these relatively simple games. There's also a nice paper that's coming out of Google DeepMind, code world models for general game playing. They've done something a bit similar. They will also get the LLMs to read the text of the game. So the LLM's got the context of the game and where that exists. And then they train it on these state action reward tuples again. And here you can see the graphs are showing the number of LLM calls required to get to high accuracy. This is on the training set and the test set. So it's showing this really learned perfect models of this. And this is given these state action reward tuples in the form of unit tests. So it's quite an effective approach. Very interesting work. However, both code-based and deep learning, I think, have a significant limitation in all the work we've seen so far, certainly all the work I've seen. So they learn from trajectories or use case sample from existing ground truth models. So they're learning where we've already got the simulation model. Okay, so it's for planning, we might need actually more abstract approximate models. So maybe the goal shouldn't be to learn an existing model. So for some planning problems, we might have lots of data that we can sample from the real world, but actually for planning algorithms, we need something different. We need simulations at a higher level of abstraction, so we can do longer planning horizon. Yeah. So what if we don't have an existing model? We might still have to get our hands dirty as engineers and go and design one, which I think is a good thing, actually. So I'm going to come on to, this is another example, some work I've been doing with an industry partner. So this is area search optimization. In this case, we're sending a set of drones into an area, contested area, so they could be lost during the search. And what we're trying to do here is to optimize the search and to keep searching it. So we've got a kind of decay factor. So we're trying to search the area. There's a heat map there showing which ones are more valuable to search. And what we're trying to do is also maintain comms links back to base. They're the red links there. In addition to optimize the navigation of the drones, they've got camera turrets on them. So we also have to optimize where the cameras are pointing. But we choose to do this as a two-level optimization. So we first of all optimize the path of the drones using this sort of fat finger approach. So the big fat sort of red lines that you see, that's a kind of very simple approximation. So if you fly down here, then you can point a camera within this kind of region and you get really, really good observations. So this gives us a multi-level. So we've got 2 levels here, the navigation, actually more levels than that, but at least 2, the navigation of the drones and the control of the cameras. And at this level of optimization, we're just doing the navigation. And this is already multi-objective. So we've got coverage, which we're trying to optimize. And they fade over time. So once areas of this that we haven't seen for a while, we're going to go back and revisit. We've got the threat survival. So things could be lost. We've got the comms factor. So we want to keep things in range to transmit back to base. And then we get a combined score. But because we're doing rolling horizon evolution, we can do this very flexibly. So in this case, we've just combined it with a weighting function, but we don't have to do that. We can have any preference function, right? Really, really simple, really flexible and powerful. Okay, so that's the area search example. Okay, the next example is Planet Wars RTS as a QR code in case you want to go straight to the website. So this is an open competition. This is a really nice challenge. You can set it for your students. You can do it yourselves. Really, really fun challenge, I think. So it's already run with Gecko 2025, IEEE Conference on Games 2025, and it's going to run with AMAS this year and also WCCI and COG. So currently, we've got a live leaderboard in the run-up to AMAS. So here's the essence of the simulation. There's a fast simulation model. It can do about 500,000 steps per second, depending on the size of the game. This is a very plannable model, easily copied. The agents have to handle significant variations. So the maps, each map is generated randomly. The planets have different sizes. The larger the planet, the faster it's able to build ships. Different transporter speeds. So for a game, all transporters go at the same speed, but they're different speeds for each game, randomly sampled. Different growth rates, full or partial observability. Let me see, have I? Yeah, so the idea is that you're trying to overtake your opponent's planets, and they're trying to do the same. So you win by wiping out your opponent or having the most ships on planets at the game end. So each planet is owned by red, blue, or neutral. Only red or blue planets grow ships and at a rate proportional to the planet size. Transporters send ships from source to target planets. And on arrival at target, if it's a friendly, you add to the number of ships. If it's enemy, you subtract from resident ships and switch ownership if negative. Okay, so that's the basis of the game. It's fairly simple, but it's a very open-ended challenge. I'm not sure why that's come up. I'm going to just do that. Yeah, so I think it's simple rules, but really complex tactics, adaptable to huge variations. Just see if I can get rid of this. I'm not sure why that's come up. Click on the plus 3 dots. Yeah. Oh, yeah. Which one's high? Do you want to have a go at that? Ah, perfect. Yeah. Messy. So that's the game. Now, yeah, like I said, these provide living benchmarks, right? So they're highly open-ended due to natural arms race. The LLM can read rule variations and generate informed heuristics, can generate complete algorithms, right? Let's run a demo. So this TypeScript demo. So actually, I wrote the code for this. I still do some coding. I don't leave everything to the LLMs. But so I wrote the original code in my favorite language, Kotlin. But then I got LLMs to port it to Python and also to TypeScript. And so for the TypeScript one, we can run this in the browser. What do I want to do there? Another. Okay, so what we're going to see now is we're going to see one of the random agents, careful random. And when I restart game, this is going to play against an agent that's entirely generated by Claude code. By the way, hands up who uses Claude code. So few, I can't believe it. Like some people don't. It amazes me. So only about a third of the audience use, maybe a quarter use Claude code. Right, so heuristic agent is going to be the blue agent on the right when I start a new game. Now, Claude read the rules. It's in the code base. So it reads all of the code of the game. It knows everything, kind of, in a sense, it knows all there is to know about the game. And I said, Claude, write me a strong agent for this. You might even consider these kind of heuristics. And it says, brilliant, I'll do it. And then it writes a report on what it's done. It says, I've got this heuristic. It's going to be defensive when necessary, be attacking when necessary. Oh, I can't wait to see this. Let's have a look. So Claude's in blue. Against careful random in red. You can see how this is going. It's not going well for Claude. But it did do a great job at doing the TypeScript version, and I've even got a full screen button, entirely done by Claude. That's brilliant. Yeah, but the agent is terrible. But we don't give up, right? Definitely don't give up. Okay, back to full screen. So what, where have I got the Claude one? Yeah, so I've played around more with Claude, and it gets some okay heuristic players, some better planning players. So by heuristic player, I mean one that's just looking at the current game state, analyzing it and say, well, I'm going to do this in a kind of rule-based way. But the rules could be complex and really, really clever, but it's not doing any forward planning. Yeah, so the best agents do planning, maybe not surprisingly. Claude does generate some average quality players. Yeah. So the other interesting angle on the LLMs and evolution is Nicky Van Stein's entry, lead developer of Lemaya, achieved 3rd place in the COG version of the competition with Galactic Armada. And as far as I know, this was entirely evolutionary LLM generated. So the LLM is generating the code, running it in tournaments, getting the feedback from the game logs, tuning the parameters. Remember, Lemaya has got SMAC built into it, so it's able to tune the algorithm parameters, and was really, really successful at that. Well, you know, fairly successful, 3rd place. So I had a lovely play with Claude Code. $100, I think pretty good value if you look at it one way. And Claude comes up with this thing. So after its first failure, it says, okay, or maybe I said to run leagues, run local round robins, evaluate these, evolve from the best ones, and let's keep doing this. And it came up with some things. So it came up with the ultimate one. This is, I think, a planning algorithm, right? So it's got various things. It's got an opponent model and so on. So it's reasonably good. But actually, win rate, these are really weak opponents. So the league it's evaluating in to only do 75% win rate against these is actually pretty poor. So although it's looking quite good locally, in a more global sense, it's pretty poor. But nonetheless, it's still interesting. And these algorithms it's writing, it's like they're now of the order of hundreds of lines of code. So it's hundreds of lines of Kotlin code that compiles, it runs, it kind of works. It's pretty interesting, I think. So little quick plug again for Rolling Horizon Evolution. So one of the key things about this is opponent modeling. And with Rolling Horizon Evolution, we can easily plug in as many opponent models as you want. So as you do your rollouts, each rollout, evaluate it with respect to a particular opponent model. And then you can do like a mini-max thing where you say, okay, I want the maximum one. Yeah, I want the maximum and the best minima, and so on. So we'll look in a minute at the current Planet Wars leaderboard. The winning team at the moment is Team Titans, And this was done by a team of master's students at the Frankfurt University of Applied Sciences, something like that. And it used human designed heuristics together with forward planning. So something like rolling horizon evolution, variation on that sort of thing. The second place is a GNN, graph neural network. Essentially the game's a graph, right? You've got different travel distances between different pairs of planets. You can think of it as a graph. Nanobosh used deep RL with an NLP. Adversarial DBA, yeah. So the DBA is the decision boundary agent, and that is if you're going to attack an opponent planet, you should send enough ships to actually win the planet. So if your opponent's got 10 ships, then how many should I send? Do I send 11? No, because by the time my ships get there, it will have grown more, and I need more than 11 to win it. I probably need to send 15. Actually, the number I need depends on how far the planet is away and depends on how fast the ships are going. So you've got to take these things into account. But that's always straightforward to do, right? And so decision boundary agent actually has these kind of heuristic rules built into it. And then what I noticed playing around with it by hand is that this doesn't take into account enough uncertainty. So actually it turned out that Claude had generated quite a reasonable agent, just hadn't tuned it. And so I went in, looked at it and did some manual tuning. And now we end up with a decent agent. So in the league, that's adversarial DBA. But so far, the planning approach is the clear winner. So this is the state of the leaderboard as of, I think, two days ago. So anyone wanting to enter this, the deadline's somewhere around the middle of May, just before the AMAS conference. So what do we see? At the top, Teen Titans. These were winners of the Gecko 2025 and COG 2025 competition. This is unchanged since last September. So this is still the one to beat. Human designed plus planning. Still hope for the humans yet. GNN, Graph Neural Network, I mentioned these already. Galactic Armada, this is the best LLM generated, evolutionary LLM generated agent we have so far. And that's down in 12th position. Nonetheless, I think quite impressive for something that didn't evolve human effort directed at this problem, right? Yeah, so we're getting close to the end. I think one of my takeaways from this is that I really personally think, yeah, there's a lot of discussion around this, I know, but I personally feel like it's a great time to be an AI engineer and a computer scientist. And I'd love to sort of chat to people in the breaks about this as well. I just think it's fantastic, right? So the models take care of all the drudge. You know, the stupid example there of adding a full screen button to my TypeScript. I mean, knowing the JavaScript or TypeScript, it's just, I don't really want to know that. It's just painful. It's just drudge. Just models take care of all that. So we're there to provide the ideas, control direction, critical evaluation. I think comprehensive evaluation and testing is more important than ever, right? So this is becoming part of the real skill. When you can generate code so cheaply, I mean, you know, I said Claude costs $100 for the weekend for that, but there are plenty of other options that are nearly as good and free, right? So code is so cheap now, but the evaluation and the overall direction of it is not cheap. But it's also hugely fun. You know, it's really challenging as an engineer to think about these critical directions that we should be pushing things in. And to get the LLMs to generate the code is just brilliant. So I think the AI and human is really a great partnership. Simulation is a superpower for AI, without question. And one that's really, in my opinion, is very, very heavily underrated, really heavily underrated. I think one thing I didn't mention enough of really is that, you know, in standard RL, you're given a fixed environment and you're trying to optimize a policy to maximize reward in that fixed environment, and to change the environment would be kind of cheating, right? You're not allowed to do that. In real world problems, you're doing it all the time, and it's one of the key skills. You're taking a complex problem, you're thinking, how can I change this into one that's easily solvable with my set of tools? So LLMs are poor at planning and game AI. Yeah, you know, in that context, they are quite good at planning in some ways. But the simulation is a key, fast, copyable, multi-level. And LLMs and EA is a really great combination. Generate heuristic functions, policy functions, write simulations, more and more write complete algorithms. I would still say still not as good as human engineers for challenging problems. But it depends on the nature of the challenge, I think. And the other thing, you know, explainable AI is really important, and simulation gives us an element of this. I'm not saying it does everything, but once we have a good simulation model of a domain, we can run, you know, if it's fast enough, we can run millions of these and look at the statistics of the outcome. We can focus on individual ones, like what's the current plan? What's it's going to lead to? And if we perturb it, if we kind of fuzzify it, how does it change? How robust is it? We can do all this with planning models, with simulation models. Yeah, so of course, you know, I believe in this a lot. I've set up a company called QuickSim Limited that I'm quite excited about. And it's, of course, for decisions you can trust, because it's all simulation based. And that's the end of my talk. Thank you so much for inviting me, and thanks for your attention. Thank you.
Well, thank you, Sam, for this part of talk. So now we have time for some questions. I kindly ask you to raise your hand so the microphone can go around.
Thank you very much. Amazing talk. I enjoyed all the way. My question is, how does this connect to the emergence of agentic AI, which is supposed to break through in 2026, 4 years after the generative AI?
Yeah, I think it connects to it very strongly. So agentic AI, the way that I think of agentic AI is using things like the Model Context Protocol, MCP. So you've got your LLM, and it's now hooked up to lots of tools, and those tools are described via some sort of protocols, something like MCP. So the LLM is now empowered to use tools to help it solve a problem. And in fact, if you look at, you know, Claude Code is already kind of doing that, right? It's using the compiler, it's using build tools all the time to analyze the code and fix it if it doesn't run. And with agentic now, we have things which an LLM might have for a particular problem, maybe 100 tools at its disposal to try and solve. And in fact, there's a fun story behind this. So QuickSim, its first contract is with Huawei in Paris, and it's a telecoms project, troubleshooting for telecoms. And they're also running an open challenge on this. So it's called Agentic AI for Telecom Troubleshooting. And it's doing exactly this, right? So you've got the LLM, you've got a whole bunch of provided tools, and the challenge there is to get the LLM to fine tune it, or to use whatever techniques you want to make the right tool calls. So imagine you've got these 100 tools at your disposal, and calling each tool on a real network has some expense to it and is a bit slow. So where that connects to this, for example, is if we can have simple simulations of this, I can now help the LLMs to choose the right tools more quickly. I think where it's overall going, you know, I said the LLMs have limitations, but when you provide them with enough tools, all those limitations, they disappear, right? Or potentially disappear if the tools are good enough and it knows how to use them, and it knows how to chain these things together into subsequent tool calls. I mean, personally, I think agentic AI is amazing. I'm very, very excited about it. Obviously, there's quite a bit of hype as well, but there's a real, you know, there's an important kind of kernel of truth in it, I think.
No questions?
Thank you. It was super interesting. You're probably already familiar with the abstraction and reasoning corpus challenge. If not, they recently published the RKGI3 benchmark, which is basically a video game. It's a set of video games where the idea is that an artificial intelligent agent has to learn how to play the game without knowing the rules. So you can just prompt actions and see what happens. You get some feedback. Are you planning to also tackle this? Because I think that it would be like important to have someone from the evolutionary community trying to do stuff like that, but it's difficult because it's complex.
Yeah, I was familiar with earlier versions of Arc, but not Arc 3. I haven't looked at that. It sounds interesting. I should definitely take a look. It's reminiscent of something I was closely involved with called General Video Game AI and the Video Game Description Language at VGDL. And there we had a whole set of really extensive set of simple games that we tested agents on. It sounds interesting. I'll definitely take a look.
You go completely blind. There are no instructions. Basically, you just play the game and try to guess how it works.
Yeah, it does. It sounds good. It does also sound similar to what we did with GVG AI. Same thing. We had no instructions, right? You were just given the model of the game, and you had to figure out what to do. I think the other thing is that for many real world problems, of course, you do have descriptions. You do, and for any game that you play, well, I guess not any game, but for a lot of games, right? They come with a set of rules that you can read, and often a set of hints as well. So I think for lots of real world problems, I think it's also interesting to say, given those hints as well, can you do even better? And for example, that's where the LLM was so effective in the maritime capture the flag, because it read the rules and said, okay, I kind of get the idea. I'm going to generate a heuristic for this. Yeah.
Questions? I kind of have a question.
Thank you so much for the definitely interesting talk. You mentioned a lot of tools for automatic algorithm generation. I am familiar with some of them, not all of them, but one bottleneck that I see there, and I don't know if this is true for games as well, is that there is a very heavy in-loop evaluation phase, right? When you want to generate something, you need to evaluate the quality at each iteration of the generation loop. And this can be heavy for two things, for two reasons. First reason is that if you want the tool to be well-performing on a broader, let's say, set of functions and instances, then you need to run your solution on all of them. Or you might want it to be effective for problems which are quite heavy to simulate. I have another interpretation of simulation, I guess, but like numerical simulations to evaluate the quality of the solution, for example. So what do you think about that? Because I see that as a quite heavy bottleneck of all of these generative loops.
Yeah, I think it's true. I don't think there's any sort of magic solutions. Yeah. I think what you can do, right, is be selective in your choice of problem. So you don't have to take things which are expensive and slow. You can, so it depends, it may be that you've got a problem to solve for a client, and that's a problem. You definitely got to solve that problem. But if you're doing research into how well these systems work, you might be able to choose something that is fast. So for example, Planet Wars, 500,000 steps per second. You can run a round robin league of heuristic agents, full round robin league in about 2 seconds, right? So the actual evaluation in that case is just about as fast, depending on the LLM system you're using. It might be nearly as fast as a code generation. It's kind of similar speed. So that's the main thing I can think of, really, is choosing things which are fast if they fit the purpose, right? And the purpose might be to say, for a challenging domain, how well can we generate code? Of course, the other thing you can do, you can pool it out to a cluster and do lots of evaluations in parallel, because the evaluations themselves, they tend to be very, very easily parallelizable. So it's that sort of thing. The other thing you can do, which is probably the most interesting one, is to develop or evolve simple simulations of the problem that are going to go so much faster, right? But that's kind of much more challenging, I would say. Yeah. Indeed. And actually, there's another thing that as humans, we're relatively good at that, I think. So I gave that example earlier of the, this was the search and rescue one. Call it search and rescue. The thing there is that I did try doing the complete evolution. So the multi-unit rolling horizon evolution of plans for the navigation and the camera control simultaneously, because that would be more optimal, right? So you really want to optimize them both together, but it's kind of hard. And the results I was getting were not as good as doing it this way. And that kind of level of human insight to look at something and say, well, actually, maybe if we decompose the problem differently, we can get better results. I think at the moment, skilled humans are still a bit better than the LLMs at doing that. I don't know how long that's going to remain the case. And it's probably already very domain dependent. Yeah.
So thank you. Thank you. We are out of time. But I think before ending this session, we can thank Simon once again.
Thank you. Thank you.
Also, I think Simon wouldn't mind to have more questions in the coffee break if you are open to, and I will give.
I would love it.
And Simon, before you go, Toulouse is also known very well for all of its space activities, and we have the chance of having both astronauts from Toulouse, Thomas Pesquet and Sophie Adenau, who's currently in the ISS. So she wasn't able to participate in this gift, but Thomas Pesquet signed this book for you. And it's a book of pictures he took from the ISS last time he was up there.
That's amazing. Thank you. Thank you.
The coffee break is outside downstairs. So you can exit this way or from above down the stairs.
Wow. What a lovely gift.
Can I get one of you just standing outside near the
Yeah. Oh, fantastic. Thank you. I have a proper look at that later. That's amazing.
You have extra load in your luggage.
Yeah, sorry about that. It's a bit heavy.
I was very interested actually. I wanted to are you worried? Small question. I would terraforming Mars.
This
You mentioned it in the context of some simulation, or
yeah, it's our environment called tag. That's it.
just take a picture of
I
the
should
slide.
put a QR code, but
Alright.
it's that's it.
Thank you. Yeah, me and my game group play a lot of terraforming Mars, and
Okay.
can show
Yeah.
them that it's like I didn't get it correct. It's a simulation where you can simulate the game itself, or
So
not an agent that
it-
plays the game.
Right. So tag is a framework for games and for agents.
Okay,
So
cool.
yeah, it does both. So it standardizes the interface in a way that, for example, we've got Monte Carlo Trisha players that will play all of the games in the framework. Not necessarily play them very well.
Yeah,
but you know,
if it's standardized, you
yeah,
can play
exactly,
all games
exactly.
with one agent.
The graphical user interfaces, they're not always very good.
It's okay.
I think so. In Pandemic, I think we've got an interface that's
It's also a
usable.
funny game, yeah.
Yeah. For Terraforming Mars, for some of them, you might not even have a good one. For some of them, it's just not there.
Okay. So,
But the big kind of power of it is that you can write an agent and with almost no effort, just play it on. You know, I say 20 games, it should be more than that now.
okay, interesting. Yeah, maybe I will look into it and then use an agent in my next game session.
Yeah, give it a
my
shot.
decisions.
For some of them, they're really not very strong.
It's okay.
For others, they are quite strong.
Yeah,
It just
but I
depends.
mean, it's just fine for the game night.
Yeah.
I'm along with my laptop and but
Yeah.
now that plays instead
definitely.
of. So, yeah. Cool. Yeah. Great
Cool.
talk.
Yeah,
Thank you.
thanks.
Nice to meet you.
This was an apartment saying they use 4 times a year, 5 times a year for
Lovely
I'm
book.
jealous.
Yeah.
for visitors. That was really nice. I don't have. Really. I did the okay, but they would visit apartment. Just very happy to systems deal with this, but you also have original input. Does it seem so? This seems like it operates really well. There's sort of an action and reaction sort of deal. Like specifically, I think about and as almost universally as an opponent to sort of teams that you and because there is such an insane decision making now affected by opponents' decisions now, those change and they change based on the kind of very reasons opponents character related to their different trajectories in terms of how they effectively interact with the world. Yeah. And there are so many different ways to reach the conclusion. Like there's so many branching paths, so that you can win in so many different ways, affecting NPCs in the game, the winning resources, being overcommitted with strategy, but it's not necessarily what you win. And so there's so many avenues for reaching the end. One of the things that I'm trying to work on constantly is the notion that even human beings have a problem where in the very early part of the game, it compounds very quickly into the opponent sort of running out of control and no recovery being feasible unless you're Dennis. And it seems like coming up with a strategy to do that sort of ahead of time, and find a strategy. That can be difficult because there isn't a cause and effect situation. Because the opponent might be playing a very different strategy from you at any time. And so you end up, I suppose, with all the average player probably ends up with a whole bunch of mental fallbacks, but they aren't necessarily effective. So from the optimization, it's very, very challenging. Just curious how the say a couple of things. Yeah.
Ouais, il doit y avoir un truc.
Tu vois qu'il y a des prises en étapes, est-ce qu'il va
C'est pour l'ordinateur?
Ouais, c'est pour l'ordinateur. Là, je suis une présentation tout à l'heure, c'est pas grave, je peux brancher. Le problème, c'est que à mon avis, ouais, je vois qu'il y a des prises en étapes, mais je ne sais pas si ça marche. Je vais voir. J'ai la question.
Je vais voir s'il n'y a pas un truc là, mais j'ai peur de tout, tout débattre.
Faire péter, hein.
C'est une tension.
avant que ça soit en panne.
Il y a un interrupteur là, mais je sais pas si.
Il y a un interrupteur.
C'est pas mal, j'ai peur que ça.
Ouais, que
C'est vrai que ça, cette lumière, ça devient un peu projecteur.
bon, si vous trouvez quelqu'un au cas où.
Et t'as dit,
Ah, moi, je suis sur un rang. Le rang où je suis, moi, ça marche pas. Oui, il y en a plein qui parlent. Mais moi, ça marche pas. Si vous voyez, marche. Un autre rang, c'est le rang buzz. Elles sont des expliquées. Ouais, je comprends.
Si vous avez rien à préparer, je vais brancher encore des coups de
Maintenant, moi, je pense que je suis
Après, tu peux prendre pied, puis le mec peut sortir.
non, j'irai après, j'ai trouvé une salle pour savoir si jamais ça peut servir.
Ouais, t'as juste demandé. T'as juste donné les locaux et ouais, c'est ça. Ouais, tout de suite.
I don't think to go there. But unfortunately, my boss. Yeah, many people get there.
C'est sur pour les sièges.
Non, les Américains, ce qu'ils font, c'est qu'ils passent l'après-midi sur le bureau. Et il va y avoir, je sais pas, il va
I know. Should I give my USB pen to you? Or no, you're the one doing it right now?
I'm part of the group.
Okay.
You can give it to me.
Okay.
Ok.
Attends, et j'ai une setup à faire.
Mais tu sais, si on a besoin de lentilles pour tester les trucs ou pas?
Celui-là, c'est celui-là qui
Ok, c'est juste celui-là.
Et après, s'ils veulent utiliser leur ordinateur spécifiquement pour raison X ou Y, ils se connectent au Zoom, ils diffusent via Zoom. On les met co-host et ils diffusent via Zoom. I'm taking the... Oh. Ah bah, vas-y, fini. Parce qu'il faut que j'arrête le live stream ici.
The system user.
Let me check. I think if I will remember, yes.
Hello.
This one?
Hello.
Yes, that one.
Okay, good. So everybody is putting the computer and everything should be set up.
Perfect. Thank you so much.
You want to put them on the computer as well? Two.
Number the 3, 3, and 4. Okay. Two cups. One is the next session, one this session, and third tomorrow.
Wow.
Here you go. Thank you. all my graduate students there. So they're very
presentations. Okay.
In case the connection.
Okay. I'll create a subfolder, go to online, and you can fetch it from there.
Yes, sorry, we don't, where I come from. Graduated this year, so my work, my master's.
Ça, c'est à nous, là. C'est là. Et celle-là, je sais pas.
Celle-là, elle est en
Oh, the University of Canada.